In the reading corner today, I'm very pleased to be welcoming Dr. Nick Crumpton. He's a paleobiologist and children's author. Nick studied ecology at the University of Leeds before undertaking an MSc in paleobiology at the University of Bristol. He went on to research for a PhD at the University of Cambridge. Nick has worked at the BBC Natural History Unit and conducted postdoctoral research at the Zoological Society of London. He currently works for the Royal Society, but is also a publishing consultant for many children's book publishers, including DK, Ladybird, and Lonely Planet. So you can see here, he also has written non-fiction, a non-fiction book called Triassic Terrors, which introduced some of the more unfamiliar dinosaurs. So you can see that he's very well qualified to help us unpick some of our commonly held myths about dinosaurs. The subject of his latest book, and the title is Everything You Knew About Dinosaurs is Wrong. It's an excitingly provocative title. Hi, Nick.
Hi, Nikki. That was such a fun introduction.
Well, before we go unravelling all of these false ideas, perhaps we can get straight from your mouth some of the facts about you. And I was particularly interested in this research into ancient mammals because they don't get as much press as dinosaurs, do they?
That's very true. Historically, they don't. I mean, if I go back to my first interactions, my early interactions with dinosaurs, I remember so clearly a really long poster that was in my brother's room when I was growing up. So they were a little bit older than me, and they had this wonderful kind of 1970s diorama of all these vicious beasts, these dinosaurs kind of holding themselves like modern day kangaroos do, enormously inaccurate. And gosh, one of them was like biting the head off another. It was really violent and brilliant. I loved it. But in the bottom, very, very bottom right-hand corner, there was a tiny little mammal, which at the time was called Megazostrodon. And I barely gave it any notice. And I remember when I was an undergrad at Leeds, I was in a lecture by someone called Jeremy Rayner, who is an incredible scientist. And he was giving a talk about the Mesozoic period and about aerodynamics and how animals from the past actually flew. And I remember him discussing an incredible animal, which wasn't a mammal, it was a kind of reptile called Charovipteryx. And it lived at the same time as the dinosaurs, but it wasn't a dinosaur. It kind of looked a little bit like a lizard. And this thing flew by holding out sort of wings, as it were, from its hind legs. So it flew nothing like any animal does today. And that was kind of a huge moment for me because I realized that everyone talks about dinosaurs. Nobody had heard about Charovipteryx. And when I then moved to Bristol to study paleobiology, everyone was really excited about doing research projects on, how incredibly strong T-Rex's jaw joints were and, big dinosaur paleontology questions. And I was drawn to the small little mammals that were alive at the time of Allosaurus and Diplodocus and all these famous big guys. So yeah, my then research at Bristol was looking at two very cute, very unassuming early sort of ancestors of mammals today, one called Morganucodon and one called Cuniotherium. And we looked at their teeth to try and work out what they were eating a very, very long time ago. And we were able to deduce that these very early mammals that were living in the same place, at the same time, when dinosaurs were doing their thing in the Jurassic period, they were eating different things. Sorry, I just got on a bit of that.
It's so fascinating. We might come back to some of that after we've explored the dinosaurs. Sure. Now, I want to get straight to the heart of the matter. I want you to clear up for us exactly what a dinosaur is, because we were taught that it's to do with the way that the legs are structured.
A dinosaur is a kind of archosaur, a group of animals which today incorporate the crocodilian forms, so things like alligators and crocodiles, also birds, so everything from blue tits to ostriches. And if we go further back in time, the archosaurs were much more diverse. So non-avian dinosaurs, everything from the enormous Patagotitan, these huge sauropods, to things like Troodon and Velociraptor and those small agile little animals, those were archosaurs as well. So all contained within that group. Yes, absolutely. The legs are certainly something that we classify as helping us identify what a dinosaur is, but there are also certain things that only they share. And that's certain things about the structure of their skull bones, but also very detailed things about, yes, their leg bones, but also their sort of hip bones as well. And when you kind of look in very, very closely at those details, then it's easy to say, okay, yes, this is a dinosaur and this isn't.
It's really interesting. I was talking to Chris Thorogood recently, who's an evolutionary botanist.
Yeah.
And it's so interesting that you just can't really tell on the look of things sometimes, because some things can look very similar, but they don't actually belong to that class.
Absolutely. And, if this is funny, that segues very nicely into my PhD research, which was, I was very interested in convergent evolution, which to all intents and purposes is exactly that. So if we look at, for instance, okay, I'm going to use moles because I did a lot of research on moles, and they're very, people don't think they're cool, but they're incredible. We're in the UK speaking, and I think a lot of people, if they were listening in North America, would just think about talpid moles. So those are the ones that we usually think of. They're like the European mole, the gentlemen in their velvet jackets. And in America, they have some slightly funkier moles, things like the star-nosed mole. They're all very, very closely related. If you spent some time in Africa, you might come across the golden moles. And if you went to parts of Australasia, you might come across the marsupial mole. If you picked up a marsupial mole, you would think that it was very closely related to a European or North American mole. I mean, it has really chunky, huge forearms, which it uses to burrow through the soil. It has has two very reduced eyes, because it doesn't really need to use them. The selection pressure for eyes has sort of disappeared. You would think it's a mole. It is a mole to all intents and purposes. However, the marsupial mole is more closely related to a kangaroo than it is to a European mole. And the golden moles that live in Africa are more closely related to elephants and manatees than they are European moles. It's just extraordinarily elegant example of convergent evolution, which we see all over the tree of life and beautifully throughout evolutionary history. So we think of moles as living in a very specific environment. Surely they could only have evolved recently. But actually, if we go back to very early in the evolution of modern mammals, after the extinction of the non-avian dinosaurs, we actually find things like Docofossa and really fun subterranean fossorial mammals living in a really similar way to modern golden moles, especially.
Now, the study of dinosaurs and fossils, it's a relatively young science. So we're still learning an awful lot about how to piece things together. When I was a child, we used to visit Crystal Park, and there are some big, massive dinosaur statues there from the Victorian period, I think. There was one of Iguanodon, I seem to recall, that had a horn on its head, which we later discover had been a large thumb. Also, we think. So what is it about the developments of the past decade that have allowed us to debunk so much of what we've learned from the earlier books and consequently given you the basis for your book?
I think that, well, firstly, that's a beautiful example that we have looking back in the history of paleontology, that we have these physical, tangible objects that you can still go visit, and they just connect us to this time period where people had never in the West really seen too many of these fossils, and they thought, what on earth were these enormous animals actually like? And they looked at animals that are large today, and I think that if we consider the leap of logic that it must have taken to look at, for instance, Iguanodon, kind of makes sense that if they find a big spike that they think, well, maybe that affixed to the skull, because we certainly don't today have any animals that have huge spikes coming off their hands. So I think that it's easy to sort of, scoff the Victorians and early paleontologists and their ideas of what dinosaurs were like. But we have to remember that not as many fossils had been found, that they were perhaps constrained by looking at biodiversity today, because we didn't know as much about the entire history of life on Earth back then to think, what could be possible. So I think within the last 10 to 20 years, which, by the way, has been an extraordinary period of time in paleontology. I think, equally as exciting as the dinosaur renaissance in the 70s and 80s, where people started thinking that actually dinosaurs might have been a little bit more active than previously they've been thought of as being. Within the last 10 to 20 years, there have been two major things that have happened within paleontology. First, the opening up and visiting and digging up of extraordinary new finds, especially from Lagerstätten in China. Just incredible fossils have been discovered there, which have radically altered our understanding of what dinosaurs looked like, and through that, our understanding of how they would have behaved. And connected to that, there have been leaps and bounds with the technologies that paleontologists are using now, and what they have at their disposal. So the paleontologists were, they weren't really paleontologists back in the Victorian period. The undergroundologists, the curious zoologists who were finding these amazing finds. They basically had comparative anatomy at their disposal. They were looking at animals today. They were looking at the skeletons and then considering what these animals might have been like. Today, we have so much technology that we can use. We have extraordinary techniques in biochemistry. We have incredible 3D X-ray machines. Today, we can also look at how modern animals, as they're move their skeletons, which give us a real big idea. So I think this has really stunningly altered our understanding of what these dinosaurs were actually like, these non-avian dinosaurs.
One of the things that I think it's really important to understand is the timeline. I love a good timeline for helping you get things into perspective. Getting a grasp on these eras helps us to get a better grasp on, how dinosaurs existed together. So I'd love you to explain a little bit about that.
Well, you're right. We're talking about dizzying amounts of time. This is true deep time, and the human brain is good for a lot of stuff. It's not good for a lot of stuff. I think, one thing it's terrible at is thinking about continuum. And so we like to group things together, but actually grouping things in terms of time periods is really useful in this regard. So if we think about the amount of time that these dinosaurs existed for when they first evolved, and then by the time of the bolide impact, which then set about the extinction of the non-avian dinosaurs, it's almost unfathomable how long they were around. So the start of the Triassic period, which is the first period that dinosaurs existed in, was 252 million years ago. To put that in context, humans haven't been around for 1 million years. Anatomical humans have just been around for something in the tens of thousands of years period. By the time non-avian dinosaurs went extinct, that was 66 million years ago. So we've got an enormous period of time there, 250 million years to about 66 million years. And I think to put that in context, when we start thinking about when different dinosaurs lived, if we take two really famous ones, Tyrannosaurus rex and Stegosaurus, the ones with the plates on its back, they live very, very far apart in terms of time. And in fact, we as humans live closer in time to a Tyrannosaurus rex than Tyrannosaurus rex lived to Stegosaurus. That's how long the dinosaurs were around for. And that's only taking it back to the middle of the Jurassic period, only the middle of this vast, extraordinary amount of time, this Mesozoic era in which they lived.
So we know that there were flying creatures in prehistoric times, the pterodactyls and Archaeopteryx, for instance. And I always thought that birds evolved from Archaeopteryx. Is that right or wrong?
Again, this is messy because Archaeopteryx, yes, for a lot of time we've talked about it as being the first bird. What we now know was that there were a lot of birds in the Mesozoic era, especially in the Cretaceous period. So working out just exactly where birds came from is a huge, enormous, active piece of research. And there are amazing researchers, especially in China, who are doing amazing work looking at where exactly the modern day birds evolved from. And we know that their entire lineage became extinct. So these were birds that, some of them maybe had teeth in their lower jaws. These were flying animals that were to all intents and purposes, looked a lot like birds, but weren't on the branch that led then directly to birds. So Archaeopteryx, yes, absolutely does look like an early member of the group of animals that eventually would become birds. Like there's no doubt of that. Like Archaeopteryx was an early bird, if you want to call it that. Let's just call it an avian dinosaur. It's much easier. But the diversity of life that we're now realizing was evident in that time period is mind-blowing, and it really is changing our idea of we will never have a clear understanding of the true diversity that was evident at any one period of time. If you think that these are animals that lived for over 250 million years and we really only know 1,000 species, it's kind of heartbreaking that we will never know about this biodiversity, which we can never know about. So we must keep digging, and we must find out as much as possible, and go dig in new places, and be aware that our current ideas of what dinosaurs were like is going to be a very small amount of the true diversity.
So you've got one spread in here, which is about skin covering and debunking the idea of green and scaly.
Right.
How much do we know about this? For instance, can we say anything about colour, or is that going to be just pure conjecture?
We absolutely can say things about colour to a certain extent, and in particular kinds of dinosaurs. So if we were to look at the skin impressions or fossilized skin, which does occasionally happen, which is occasionally found, it's highly unlikely that we could get an understanding of the true coloration of sort of this reptilian skin. What became very exciting within this last decade or two was when the first feathered dinosaurs began to be discovered. It then became possible for very, very close looks to be taken at these feathers and to analyze the pigments that were actually fossilized within them. So there are structures that can be viewed, and some of them do fossilize very, very well. There's a little bit of debate over whether the colors, whether they are accurate, or whether the very small sort of protein packets, whether they've actually been altered through taphonomy, through the fossilization process. But if we say that they haven't, then we really can see that some of these feathered dinosaurs had banding on their tails and on their feathers. We know that some of them appeared to be quite dark in color. A sort of reddy, rusty color comes up quite a lot. Things like Sinosauropteryx. Just extraordinarily, we are able to now color some of these feathered dinosaurs, and really nicely with some of the coolest ones. So Microraptor, which is in the running to be one of my favorite dinosaurs, which had 4 wings. It had wings coming off its forearms, but it also had wings coming off its back legs. We know that it was very dark in coloration. It probably looked a lot like a modern day crow. It had this very dark plumage, and that's all thanks to them evolving feathers.
That is amazing.
So for a few dinosaurs, yes, we can really clearly see, and actually there are a few where we've got really, really amazing understanding now of coloration. Things like Psittacosaurus, which was related to Triceratops and those sort of horned ornithischians. We do know something about its colorization, and it does seem that it actually has this is so nice. It actually looks like it has counter shading, which meant that it was slightly darker on the top and lighter on its belly. This is something that's turned up multiple times. This is convergent evolution, and to now have biochemical evidence of that really is breathtaking, and again tells us more about the paleobiology of this organism.
So I want to ask something a little bit about the way in which the book is written. The thing that I really liked is that the scientific process is made a little bit explicit for children. And I think in the past, we were more concerned with producing books that gave children facts. I really appreciated this kind of inquiry approach.
Thank you. I guess this is a book that presents facts, but also talks about facts. The idea of it, everything you know about dinosaurs is wrong, means that on every page, I take a statement and then kind of disprove that statement, or at least show lines of evidence that we are now aware of, in contemporary 2021 paleontology, which maybe questions these things, which kids might have heard of a lot. For instance, one of our pages is raptors slashed their prey. So, if you watch Jurassic Park, there's that wonderful scene at the start where Alan Grant takes out that claw and scares the kid by saying, okay, it's gonna, cut your belly open and your intestines will come up, blah, 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 blah. It's great, it's gross, it's cool. All of our current research shows that potentially it'd be very difficult for raptors of any size to use their claws like that in a real slashing motion, and much more likely they use those long claws to pin down their prey in a very similar way to modern raptors, as it were, so birds of prey. So I think it's fun in the way that the book kind of takes these ideas, these phrases that they will have been aware of for a long time. They would have been told through TV shows. They would have been told through films. They would have been told by their parents and people that know, a little bit about dinosaurs. But I think what the book then tries to do is show how science works, and that is basically don't trust anyone. I work for the Royal Society, and their motto is nullius in verba. Don't take anyone's word for it. If you are given a fact, there is nothing wrong with saying, is that really true? To what extent has that been proved? And that is exactly how science works. It's all about the accepting or the rebuffing of hypotheses based on evidence. That isn't to say that nothing can be believed, and it isn't to say that everything you have been told about dinosaurs is completely wrong. It's a very fun title, but we try to make sure that kids know that actually the information that is in this book, it's right at the moment, but actually new dinosaurs are being found every single day. New papers are being published in countless journals every single day, and there are quite literally thousands of paleontologists around the world that are working on these questions and finding new things out. And we kind of end the book, spoilers, by saying that potentially things in this book are going to be shown to be wrong. And that's cool. That's how science works. And I think a mistake that a lot of books make when talking about dinosaurs is that they treat the concept of dinosaurs as a very static science, one that doesn't move fast. And I think that it's really lovely in this to really highlight that there are scientists actively working to kind of work out whether everything we know about dinosaurs, what can be trusted, and maybe whether there are things that can be shifted. That's science. Science is a dynamic, fluid, fluctuating thing, which is why it's so exciting, which is why it's so cool to be a scientist, to take, all these textbooks that we have and just be like, okay, someone thought this once based on the evidence that they had, but we now have more evidence. Do we still think that? And that's what I tried to do in this book. It's a book about dinosaurs, but it's also a book about paleontology. It's a book about the history of paleontology. It's a book about being a paleontologist, and it's a book about how science works.
Brilliant. And that sums it up beautifully. And I have to say that there are going to be many young readers out here for who a much simplified book just isn't satisfying enough, and they're going to get huge amounts of satisfaction from this. I have to end with one final question, and it's going to take us back to the beginning. When are we going to see books about the little creatures?
Yeah, wow, I would love to see a book about, Megazostrodon, Morganeucodon, Cunitherium. They are super duper interesting, and maybe I am pitching some stuff right now, but we'll have to see whether anything gets out there.
Yeah. Thank you so much for talking to us, Nick, today in the Reading Corner. It's been a huge pleasure.
Thank you so much for having me on the show. Really, it's been a delight.
In the Reading Corner is presented by Nikki Gamble and produced by Alison Hughes. If you have enjoyed this podcast, please do leave a review for us. To find out about other projects, including an audience with events and the Exploring Children's Literature Summer School, visit www.exploringchildrensliterature.uk. Join us again soon in the Reading Corner on your favourite podcast platform.